Let us now look at how to name acids. The first thing to know is that there are two types of acids: binary acids and oxyacids. Let us begin with the binary acids. Binary acids are made up of only two elements. That is where the word binary comes from, which means two. What are the two elements? Hydrogen, which will always be present in any acid, and any other nonmetal. The only nonmetal that will not be among the binary acids is oxygen. So no oxygen. Let us take a look at some examples of binary acids. HF, HBr, H2S, H2Te. All of these are binary acids. As you can see, only two elements are involved and there is no oxygen. Naming them is very straightforward, but let me quickly mention something here. As written right now, HF can also be called hydrogen fluoride if it is a gas. But to indicate that we are talking about acids, you will see AQ in front of the HF, which means aqueous, which means HF gas has been dissolved in water to make acid. So the same thing for HBr, which means it has been dissolved in water to make acid, in H2S, in H2Te. So the aqueous is an indication that you are not dealing with a gas. Naming binary acids is as simple as this. You will write hydro as the first prefix. Then you write the base name of the nonmetal, and then you must end the name with "ic" and acid. Let us apply that format to all of the examples we have up here. So the HF will begin with hydro. Only the binary acids begin with hydro. Then the base name of the nonmetal would be fluor, and we add ic acid, which means this is hydrofluoric acid. The same way, this will be hydrobromic acid. This will be hydrosulfuric acid. This will be hydrotelluric acid. Again, remember that only the binary acids will have hydro as their prefix. The oxyacids, as their names imply, will have oxygen in them. Their names must not begin with hydro. Let us take a look at some oxy acids. Let us write out their formulas so that you actually can remember. If you look at all of the polyatomic ions I have on the screen right now, they all have oxygen in them and they all have charges on them. To balance out all the negative charges on all of them, we will need to include positive hydrogen charge. I need you to note right now that anytime you see H with a positive charge on it, that is telling you that you are dealing with an acid. So, NO3 with a charge of -1 on it will become HNO3, dissolved in water, because the +1 on the hydrogen will balance out the -1 on the NO3. NO2 with a charge of -1 on it will then become HNO2, dissolved in water. SO3 with a charge of -2 on it will then form H2SO3 aqueous as the acid. SO4 with a charge of -2 will lead to H2SO4. PO3 with a charge of -3 on it will form H3PO3, and we will add the aqueous to indicate that it is dissolved in water. PO3 with a charge of -3 on it will need 3 hydrogen, so it will be H3PO4 aqueous. ClO will be HClO aqueous. ClO2 minus will lead to HClO2. ClO3 will lead to HCl. ClO3 will lead to HClO3, while ClO4 will lead to HClO4. The question then is, how do we name these acids that are written in red? The simple format to naming them is that if the polyatomic ion that generates the acid ends in ITE, then the name of the acid itself should end in OUS. While if the name of the polyatomic ion that generates the acid ends in ATE, the name of the acid itself should end in IC. Let us take a look at what that means. Let us begin with this first one. It is generated from nitrate, and it should become IC. So this acid will simply be nitric acid. That easy. Remember, there should be no hydro in front of oxy acids. Let us take a look at HNO2. The polyatomic ion that generates it ends in ITE. So the acid itself should have a name that ends in OUS. So this would simply become nitrous acid. H2SO3 ends in ITE in the polyatomic ion. So the acid itself should be sulfurous acid. H2SO4 is a very common acid. The polyatomic ion that generates it ends in ATE. So the acid itself should be sulfuric acid because 8 becomes ic. H3PO3. The polyatomic ion ends in ITE, so the acid itself should be phosphorus acid, while H3PO4, because it is generated from phosphate, should become phosphoric acid, which is also a very common acid. HClO, because it is generated from hypochlorite, should become hypochlorous acid. HClO2, because it is generated from chlorite, should become chlorous acid. HClO3, because it is generated from chlorate, should become chloric acid, while HClO4 should become perchloric acid. That is how to name acids.